Observatories around the world are urgently reorienting their telescopes to independently confirm the Chinese detection and collect additional data that might clarify whether the object is truly the return of original 3I Atlas or a separate visitor with similar characteristics. The Very Large Telescope in Chile, Keck and Gemini observatories in Hawaii, and internationally coordinated networks of smaller telescopes are dedicating priority observation time for high-precision astrometric tracking, detailed spectroscopy and photometry that will characterize the object's properties. Additional radio telescopes, including the Very Large Array in New Mexico and European facilities, are being scheduled for When 3I Atlas completed its passage through perihelion and began accelerating back toward deep interstellar space, the global astronomical community assumed we were bidding a definitive farewell to the most anomalous visitor ever detected. Its hyperbolic trajectory confirmed extrasolar origin, and basic orbital mathematics predicted it would continue accelerating as it moved away from the Sun's gravitational influence, eventually disappearing beyond the reach of even the most powerful telescopes. For objects in hyperbolic orbits, there is no return, only a one-way journey back to the interstellar void from which they came. The last detectable photons from 3I Atlas were captured in April 2026, and from that moment on, the object should have become permanently invisible, lost in the cosmic depths. Scientists had solid reasons based on established orbital physics to believe we would never detect 3I Atlas again. Interstellar objects don't orbit the Sun in closed ellipses like resident solar system comets. They follow open hyperbolas that carry them away forever after a single close pass. The escape velocity necessary to permanently leave solar influence had already been reached, and each passing second increased the object's distance exponentially. Even if we wanted to send a probe to intercept it, the window of opportunity had closed irreversibly. The farewell was definitive, or at least it should be according to everything we understand about celestial mechanics. Filing 3I Atlas away as an extraordinary but closed case seemed to be the natural destiny of the story. The new detection made by Chinese observatories, specifically the Fast Radio Telescope in Guizhou, the world's largest single-dish antenna, spectacularly detonated this comfortable narrative. In November 2026, operators detected an anomalous radio signature coming from a region of space that didn't correspond to any known catalogued object. Preliminary analysis of the spectral signature revealed characteristics that perfectly matched the profile of 3I Atlas documented during its previous passage. Emissions at specific frequencies consistent with anomalous chemical composition, polarization patterns identical to those observed months before, and pulse timing suggesting an object rotating with a period similar to that recorded. When astronomers calculated the apparent position of the source and compared it with the trajectories of all known interstellar objects, the disturbing conclusion emerged. Either 3I Atlas had inexplicably reversed its trajectory, or something with an identical signature was now occupying a region of space where the original visitor should never be. The spectral signature captured by FAST was not ambiguous or subject to multiple interpretations. It was an almost perfect match with the unique characteristics of 3I Atlas extensively documented during its original passage. Radio telescopes detect celestial objects through the radio waves they emit or reflect, and each object possesses a unique spectral fingerprint based on its chemical composition, temperature, magnetic field, and motion. The profile detected in November showed emission lines at 1,420 MHz consistent with neutral hydrogen, a 2.8 GHz component suggesting complex organic molecules, and anomalous peaks at frequencies that had previously been attributed to possible vaporized metallic compounds in the object's coma. The probability that two different objects would produce such similar spectral signatures by pure chance is astronomically small, analogous to finding two people with identical DNA who aren't twins. Complementary spectral analysis using optical telescopes that visually confirmed the radio detection revealed anomalous composition identical to that observed in the original 3I Atlas. Inverted CO2, H2O ratio, complex organics in abundances that violate cometary formation models, and traces of heavy elements that shouldn't be present in a pristine body from the interstellar medium. High-resolution spectrographs identified the same absorption and emission lines that had intrigued astrophysicists during the first passage, confirming that not only was the radio signature identical, but the entire chemical composition corresponded with disturbing precision. If it were a different object with coincidentally similar composition, that alone would be an extraordinary discovery challenging our understanding of chemical diversity in interstellar objects. But the combination of identical spectral signature and detection timing forced consideration of the simplest explanation. However impossible it seemed, it was the same object. The small orbital variations detected through precision astrometric observations over several nights revealed the most disturbing aspect of the situation. The object wasn't simply continuing on a predictable hyperbolic trajectory based on its last known position in April. It was in an orbit that appeared to have been altered in ways we cannot explain using only solar and planetary gravity. Retrograde calculations attempting to reconstruct how the object arrived at its current position from its previously known trajectory failed to produce a consistent solution without invoking massive non-gravitational accelerations of unknown origin. It was as if 3I Atlas had executed an impossible return maneuver, decelerating its hyperbolic escape and reversing direction to return to the inner solar system, something natural objects on escape trajectories simply don't do without significant external assistance or active propulsion. The first hypothesis astronomers explored involved unknown or inadequately modeled gravitational force that could have deflected 3I Atlas during its journey out of the solar system. Perhaps the object passed near an undetected dark matter concentration, whose gravity provided a gravitational push that altered its trajectory in ways we didn't predict. Or possibly there was a close encounter with an uncatalogued dwarf planet in the outer regions of the solar system, providing gravitational assistance that decelerated and redirected the visitor. These explanations have the advantage of requiring only known physics, without invoking exotic processes. But the critical problem is that the magnitudes of gravitational deflection necessary to explain complete return would be enormous, requiring significant mass in locations that should have been detected by infrared surveys that mapped the outer solar system. The second hypothesis, one that few scientists verbalize publicly but many consider privately, is that the orbital change represents deliberate movement executed through some form of active control over the trajectory. If 3I Atlas possesses propulsion, even modest, it could have executed a series of calculated burns to reverse its hyperbolic trajectory and return to the inner solar system. The physics is straightforward. Decelerating from hyperbolic escape velocity requires velocity change of only a few kilometers per second, achievable with conventional propulsion systems that our own technology possesses. The timing of the maneuver could have been chosen to occur when the object was beyond the reach of terrestrial telescopes, avoiding direct detection of the propulsion process. If this interpretation is correct, it would imply the object is not natural and that its visit to the solar system resembles more a deliberate exploratory mission than a casual encounter. The third possibility, perhaps most disturbing, is that we're interpreting the data fundamentally wrong and what was detected is not the return of the original 3I Atlas, but a second object with identical properties arriving at coincidentally similar timing. This hypothesis would suggest that objects with 3I Atlas's anomalous characteristics are not rare unique visitors, but possibly part of a larger population of similar artifacts navigating the galaxy. If multiple objects of this type exist and occasionally cross our solar system, it would completely transform our understanding of the prevalence of anomalous interstellar phenomena. But astronomers warn that none of these explanations fully fits the data without requiring improbable coincidences or physical processes that transcend our current understanding, leaving the scientific community in a state of genuine perplexity about how to interpret the apparent return of the most enigmatic visitor ever detected. NASA's official reaction to the Chinese detection was characterized by extreme caution bordering on institutional silence. Spokespersons confirmed the agency is analyzing data shared by Chinese colleagues through established scientific channels, but refused to make any substantive statement about the nature or origin of the detected object. Public communications were limited to generic technical phrases about the need for independent verification and rigorous analysis before preliminary conclusions, carefully avoiding any language that might suggest the situation is extraordinary or concerning. This communicational reticence contrasts dramatically with the relative openness NASA demonstrated during 3I Atlas's original passage, when regular updates about observations were provided through multiple channels. The current silence suggests something about this new detection is causing significant institutional discomfort. Internal sources report that concern within NASA is focused on two main aspects of the Chinese data: the almost impossible precision with which the spectral signature matches the original object, and the implicit return velocity that preliminary calculations suggest. If it's really the same object, it would have had to decelerate its hyperbolic escape and reverse direction on a timescale of months, something requiring non-gravitational accelerations of magnitude we've never observed in a natural comet. Trajectory engineers within the agency apparently ran multiple simulations attempting to find natural scenarios that could produce the observed return, and all failed to replicate the data without invoking forces or processes we don't understand. This inability to explain the phenomenon using established physics is generating intense internal debate about how to communicate the situation to the public without feeding uncontrolled speculation. The international scientific community is on maximum alert not just because of the detection itself, but because of the institutional response pattern that seems to repeat exactly what happened with Oumuamua and Borisov. When genuine anomalies are detected in interstellar visitors, space agencies seem to enter information containment mode, sharing raw technical data but avoiding interpretations or discussions about broader implications. Independent scientists without institutional affiliations that force self-censorship are more willing to openly discuss the possibility that 3I Atlas represents something beyond a natural phenomenon, but their voices are frequently marginalized as non-rigorous speculation. The tension between scientific need to honestly consider all hypotheses and institutional pressure to avoid extraordinary claims is creating an environment where the true nature of the phenomenon may be obscured by political and reputational considerations that have nothing to do with scientific method. The possibility of multiple objects similar to 3I Atlas traversing the solar system regularly or irregularly would completely transform our understanding of the nature of the interstellar medium and what's navigating through it. If the detected object is not the return of the original but a second visitor with identical characteristics, it implies existence of a population of similar artifacts distributed throughout the galaxy in sufficient numbers that encounters with our solar system aren't extremely rare. Statistical estimates based on interstellar visitor detection rates suggest we only see a minuscule fraction of objects that actually cross our system, because most pass unnoticed by being too small or not approaching close enough to the Sun to become bright. If objects with 3I Atlas's characteristics are common enough for multiples to appear in a years-long time window, this suggests interstellar space may be much more populated with these artifacts than we previously imagined. The challenge of tracking bodies that don't follow predictable gravitational laws represents a fundamental problem for planetary defense programs and near-Earth object surveillance. All our detection and cataloging systems assume objects follow orbits determined only by gravity, allowing long-term predictions about future positions based on past observations. If interstellar visitors can alter their trajectories through non-gravitational means, whether active propulsion or natural processes we don't yet understand, all those predictions become unreliable. We could calculate that an object is on a safe trajectory that doesn't cross Earth's orbit, only to discover months later it executed a maneuver that completely altered its route. This unpredictability introduces an element of uncertainty that our current protocols weren't designed to handle, requiring development of new continuous monitoring methods instead of prediction based on deterministic orbits. The impact that confirmation of controllable interstellar visitors would have on galactic formation theory and the search for cosmic intelligence would be revolutionary on a scale comparable to the discoveries of Copernicus or Darwin. If technological artifacts routinely navigate between stellar systems, it implies at least one civilization, and possibly multiple, developed interstellar exploration capability and are actively using that capability for purposes we can only speculate. Galactic formation theory would need to incorporate the possibility that at least some civilizations survive long enough to become spacefaring on interstellar scale, challenging Fermi paradox arguments that assume such civilizational longevity is impossible or extremely rare. The search for extraterrestrial intelligence, traditionally focused on detecting radio signals from distant stationary sources, would need to expand to include detection and characterization of physical artifacts that may be actively exploring our galactic neighborhood right now. The universe would cease being an empty place punctuated by rare islands of life, becoming a galaxy potentially filled with civilizations whose probes cross our path frequently enough that multiple detections are possible on human-year timescales. Observatories around the world are urgently reorienting their telescopes to independently confirm the Chinese detection and collect additional data that might clarify whether the object is truly the return of original 3I Atlas or a separate visitor with similar characteristics. The Very Large Telescope in Chile, Keck and Gemini observatories in Hawaii, and internationally coordinated networks of smaller telescopes are dedicating priority observation time for high-precision astrometric tracking, detailed spectroscopy and photometry that will characterize the object's properties. Additional radio telescopes, including the Very Large Array in New Mexico and European facilities, are being scheduled for complementary observations that will confirm or refute the radio spectral signature reported by FAST. Each night of clear sky brings potential for data that could definitively resolve the nature of the phenomenon or deepen the mystery even further. The coming weeks represent a critical period that could fundamentally redefine everything we thought we knew about interstellar visitors and their prevalence in our galactic neighborhood. If independent observations confirm the object possesses spectral signature identical to original 3I Atlas and trajectory consistent with return of the same body, we'll face the need to explain how a natural object reversed hyperbolic escape orbit, something unprecedented in astronomy's history. If analyses reveal it's a separate, coincidentally similar object, we'll have to confront implications that such anomalous visitors are common enough for multiple detections in short temporal period. Either scenario forces dramatic expansion of our models about what exists in interstellar space and how frequently it crosses our solar system. The possibility that we're witnessing first detections of a galactic population of exploratory artifacts can no longer be dismissed as fringe speculation, but must be seriously considered as testable scientific hypothesis. If 3I Atlas truly returned, if objects can reverse escape trajectories and deliberately return to systems they previously visited, the universe may be trying to tell us something that fundamentally challenges our understanding of our place in the cosmos. Perhaps we're not passive observers of a mechanical universe governed only by gravity and chance, but participants in a galaxy where intelligence is common enough to leave detectable marks in the form of exploratory artifacts navigating between the stars. The implicit message in the apparent return of the most anomalous visitor ever detected is that the universe is a stranger, more populated, and potentially more intentional place than our physics prepared us to accept. The telescopes are pointed, the data is being collected, and within weeks we'll know whether this detection represents observational error, extraordinary natural phenomenon, or confirmation that interstellar visitation by technological artifacts is a reality our civilization needs to learn to recognize and understand. The new mystery is no longer whether 3I Atlas was anomalous, but what its apparent return reveals about the true nature of the space surrounding us.